Hello students, today in the equilibrium chapter we are discussing about the what? That is the dissociation of weak acid. What is the meaning of this dissociation of weak acid here? So just to take the one explanation here. There is the, let us consider a dissociation of weak acid HX, dissociation of a weak acid HX in aqueous solutions, solution. So that we have to write on the expression, that is the HX. This is what we are calling as a weak acid HX. So when this HX, when you add it into the water, so then what comes here? That is it is in the form of what? Aqueous form. That is, it is in the form of liquid is there. So any acid, weak acid, when you dissolve it in the water, then what happens here? It forms what? It will dissociate into what? Dissociate into H3O plus that is it gives what? X minus. Okay, they both are in the what? Aqueous form here. Aqueous form. So this H3O plus and X minus, again they are combined to what? HX and H2O. So this is the what? The dissociation of weak acid here. When the weak acid, when you are adding into the water, so then what happens here? It splits into what? Hydronium and X minus. That is the halogen is there. X means what? Any halogen is there here. So that is the what? We are taking one example here. So here in the initially the concentration will be, we are writing the initial concentration here. That is initial concentration. What is the initial concentration? Concentrations are there here. That you are writing. The initial concentration will be, for the reactant you have to take what? C. This is the weak acid is there, no? That you have to take, consider the initial concentration of this weak acid will be C is there. So in the case of H2O, you don't take care, that is it is in a large quantity is there, so you have to left that one. So when you starting the reaction here, what happens here? The concentration of HX will be C is there. This is the liquid water is there, you cannot take that one. So here the product is still not formed here, means its concentration will be what? It is not formed here, so its concentration will be 0. Initially what happens here? The reactant are converting to product is there. Initially when the reaction starts now, initially the reactant concentration we have to take as C. Water we are not taking here, and still the reaction is not going on here. Means the product is not formed here. Means so you have to take the concentration for initial concentration as a 0, 0 at the product side here. Next one, you see here the initial at equilibrium, when the reaction going on HX, when it combines with the water, so it gives what? It splits into what? It undergoes dissociation into H3O plus and X minus here. So here this reaction, first forward reaction takes place. Then what happens here? The reverse reaction is going on. That is the H3O plus and X minus combines into what? HX and H2O. So here when the equilibrium is attained here the equilibrium is when the equilibrium is attained, at equilibrium, what happens here? You see here, what is the concentration is there at equilibrium here? The concentration will be what happens here? See the concentration of this HX, and it will be what? It will be decreases. How much it will be decreases? Minus C alpha. So initial concentration is C is there, then afterwards what happens is C alpha, what it indicates here? The concentration will be decreases here. Why it will decreases? The rate of velocity of reaction, at that time I have explained that the reactant concentration always it will be reduces and the product concentration will be increases. So here what happens? The concentration will be what? Reactant concentration decreases, then only product form now. So because of that, then we have written on C minus C alpha. What is C alpha? It indicates that is the decrease in concentration. What is alpha is this, sir? You have to write down here. Alpha is the extent of dissociation. Extent of dissociation. Extent of dissociation. Okay. C minus C alpha is written. Next one here, what is here? That is the C alpha. That much concentration will be increases here. Here the concentration, product concentration increases, reactant concentration always decreases here. How much will be increases here, sir? Here means so C alpha means that much amount will be increases here. C alpha amount of concentration increases of the product of the hydronium ion, and X minus ion concentration C alpha into C alpha, C into alpha, that concentration will be increases. Here decreases, reactant side it will be increases here. Okay. Next one you have to consider here is that is the applying a law of mass action, where C is what? C is the initial concentration, where C is initial concentration. Initial concentration. C is what? Initial concentration. Okay. Concentration of undissociated acid. Undissociated acid. Okay. Now what we have to do here means, this is the way C is what? I have written here. C is the what? Initial concentration of the undissociated acid. So next, apply law of mass action. Apply law of mass action. When you are applying the law of mass action, then what happens here? That is the Ka. You have to take what? Ka is equal to dissociation constant. Ka of a weak acid is equal to what? Is equal to, you have to take what? The number product of the molar concentration of the dissociated molecule to the what? The molar concentration of the product of the molar concentration of the dissociated molecules. Then you have to write down what? That is the H3O plus into X minus, in the bracket write down Hx. So we are not taking, sir, H2O. H2O if we are taking is a what? Unity. That is 1 is there. Because of that unity we are taking the liquid, we have to take pure liquid is there, that one. What is the pure liquid? So because of that reason we are taking as a unity, that we are left in that one here. Only Hx. What is the next step is there, sir? We have found out that the Ka. Then what we have to do, sir, here? So next one, it is called, so you have to write down here, getting the confusion here means note. In the note you have to write down, that is the H2O taken as unity. Unity means what? There is a 1. The value you have to take is 1 here. So that completes here. Next one, you have to see here Ka is equal to, you see here H3O plus is there. H3O plus, what is at equilibrium, what is the value of the concentration? That is C alpha is there. That I will write down here. C alpha. Okay. Next one, you see the X minus is there here. What is the concentration here? Is there here? So C here, C alpha is there. Then you have to write down into C alpha divided by Hx. What is the value this time? C minus C alpha. That we have to write down. C minus C alpha. Oh. So when you multiply this one, C into C square, it becomes what? C square, alpha into alpha square divided by, if I taken the common here, what happens here? C into 1 minus alpha it becomes. Okay. This is 1C and this C is will be cancelled each other means, so what are we getting here? We are getting what? The C alpha square divided by 1 minus alpha. So this is what we are calling it as a dissociation of what? Weak acid formula. Ka is equal to C alpha square divided by 1 minus alpha. So it is also called what? It is also called what? That you have written here as a, this is called as a, this is called Ostwald's law of electrolytes. Ostwald's law of electrolytes. So this is the what? Dissociation of what? Weak acid is there, this one. So if you are having the dissociation of weak acid is there, that means that is Ka is there, this one. If you are returning into in the form of what? In the pH scale, if you are taking Ka, dissociation constant of weak acid, that you are taking in the pH scale here, means that one you have to write down this one as what? pKa. That you can also write down what? pKa is equal to negative logarithm of base 10 to the Ka. When you are taking this one into the pH scale. So when you are taking into the pH scale, what happens here? That is the pKa. It converts into what? pKa is converted into minus log Ka to the base 10 here. Then how we are defining this one? This one when you are converting into the pH scale. pH scale when you are taking pH is equal to what? My negative logarithm of base 10 to the hydrogen ion concentration. Like that you are taking, when you are Ka, when you are taking in the pH scale, that it becomes what? pKa equal to minus negative logarithm of base 10 to the Ka. So now what is the definition for pKa is there here? pKa definition I will write down here. Definition. What is the definition is that? pKa is defined as negative logarithm of base 10 of dissociation constant of weak acid. So this is what we are calling it as a pKa. What is the meaning of pKa here? That is it is a defined as the negative logarithm of base 10 of the dissociation constant of a weak acid. Dissociation constant of what? Weak acid here. So this is what we are calling as a pKa. So this is the very important one here, the formula. pKa is equal to negative logarithm of base 10 to the dissociation constant of a weak acid. So in this formula we are using in the solving the problems here. The next one, dissociation of a weak base. Next one you have written down. The next one, dissociation of dissociation constant of Otherwise, you can also write down dissociation of only. Dissociation of or dissociation constant of. Dissociation of weak base. Dissociation of what? Weak base. Okay. So in the first class we have studied about the dissociation of weak acid. Here what we are studying here means so dissociation of weak base is there. So then let us consider the dissociation of weak base BOH in aqueous solution. So consider the dissociation of what? Weak base BOH in aqueous solution. So here we have written down the reaction. Consider one reaction BOH. When you are adding it to the water or it undergoes directly dissociation. So what it gives here? So it is undergoing the dissociation. It gives what? B plus OH minus. Okay. Both are in the aqueous form. That word product. Here it is at aqueous form. Both are in the aqueous form. So in this reaction, in the last one, dissociation of weak acid is there means so we are taking their acid reaction we are taking. Here what comes here? Base we are taking. BOH is a what? Base there. Okay. So this is undergoing the dissociation here. So just you have to write down the first one, initial concentration. What is the initial concentration of BOH is there here means concentration will be C is there here. First reactant side you have to take the concentration will be C. In the product side what happens here, still it is not formed initially. First reactant is coming, then reactant react to the what? Product here. So here product concentration you have to take what? 0. Okay. When the reactant is converted into product, then after some time the product is also converting what? Reactant here. Then at equilibrium, what happens here? At equilibrium, what is the concentration is there here? Same. You are writing C minus C alpha. Why you are taking C alpha here? The concentration of will be decreases as time goes. Okay. As time passes, the concentration of reactant will be decreases. Product will be increases. How much it will be increases? C alpha. Alpha is what? Extent of dissociation. Okay. So next one, you see here. So same way as we have to write down the KB you are writing. In the last one you are writing the K, that is the weak acid. This is the weak base. KB is equal to what you are writing down? That is the B plus into OH minus. That you are writing down. B plus into OH minus divided by you are writing down BOH. Next, you see here, you put that values. What are the values you are having? B plus means what you are having? C alpha. BOH means what you are having? Into C alpha. Divided by what you are having? BOH. BOH means what you are having? C minus C alpha. C minus C alpha. That is what we are going to weak base KB. Okay. So here, your KB is there, then you have to write down KB is equal to what you have to write down C alpha into C alpha, what it becomes? C square alpha square divided by, I will take the common here, C into 1 minus alpha is there. This C and this C will be cancelled each other, then you are getting what? That KB Then Kb is equal to what you are writing? C alpha square divided by 1 minus alpha. This is what? K is equal to C alpha square divided by 1 minus alpha. So that what it indicates here means that is a Kb, the dissociation of what? Weak base. That is also where dissonant reaction is also called what? That is this is the equation for the Ostwald's law of electrolytes. Okay. Next one, if you are writing this weak acid in terms of pH scale, when you are converting, then this Kb it becomes what? P Kb equal to negative logarithm of base 10 to the Kb. When you are converting into the, that is a pH scale, that definition according to pH scale, then pKb is equal to what? Negative logarithm of base 10 to the Kb, dissociation of weak base here. So we can what is the definition is that the pKb can be defined as definition. What is the definition there? The pKb is defined as pKb is defined as negative logarithm of base 10 to the base 10 of dissociation constant of dissociation constant of weak base. This is called what? pKb. So what is the meaning of pKb? pKb is defined as negative logarithm of base 10 of dissociation constant of a weak base. That is pKb is equal to negative logarithm of base 10 to the dissociation constant of what? Weak base. So this is what we are calling as the dissociation of what? Weak base here. So in this one you have to remember here the lower the value of pKb, very important point, lower the value of pKb, what happens here? When it is having lower the value of pKb, stronger is the base. If the pKb value is low is there, means lower the value of pKb, then you write what? Stronger is the base. In the last also you can also write down that one is the lower the value of pKa, stronger is the acid. That is also we are written here. Okay. So this completes the dissociation of weak acid and the dissociation of what? Weak base here. Next one, we have to move towards the that is we have to prove that pKa plus pKb is equal to 14. Prove that there is a pKa plus pKb equal to 14. That you have to prove here. So you have proved the ionic product of water. That is also you have proved the pH plus pOH is equal to 14. Now you have to prove what? pKa plus pKb is equal to 14 here. This is also very important one here. For the 2 marks they can ask questions. Very important one. How to prove that one here? So that we know that what we know, there is the Ka into Kb equal to 10 raised to minus 14. 10 raised to Ka into Kb, dissociation constant of weak acid into dissociation of weak base equal to what? 10 raised to minus 14. So this we know that one. Suppose here when you multiply the negative logarithm on both sides, then what happens here? Take negative log on both sides. Take negative log on both sides. Then what becomes here? Log of Ka plus negative log of Kb is equal to log 10 raised to minus 14 is there. Log 10 raised to minus 14. Okay. So you can already know log m raised to n. What do you do now? N log m. So then it becomes what? Minus log Ka plus negative logarithm of Kb is equal to what comes here? Log m raised to n is there, means so you have to write down what? N log m means, so it becomes what? Minus 14. You have to take negative logarithm of, you have to make here negative and here outer side is negative is there. Negative logarithm of base 10 to the 10 is there here. So already you know that is a log 10 value will be what here? Log 10 value will be 1 is there. 1 into minus 14 minus 14. Minus 14 into this minus. Here you are taking the negative logarithm. So negative logarithm you are taking minus into minus, that becomes here plus here. Then what you are getting? Then also you see here negative logarithm of Ka, negative logarithm of Kb. So that we have already seen on this class only. That is a negative logarithm of Ka is there, means what you have written down here? pKa. Negative logarithm of Ka is there, means pKa plus negative logarithm of Kb is there, means pKb. Okay, pKb equal to what happens here? Log 10 value will be 1 into minus 14 minus 14 into minus, that becomes what? Plus 14. Then we have proved that pKa plus pKb is equal to what? 14 here. So these are some important formulas are there. pKa plus pKb is equal to 14, pH plus pOH is equal to 14. That is a very important formula that is becoming so in the problem. So we are using this one here. Next one we have to move towards the problems here. Problem. So that is the first one. The dissociation constant of dissociation constant of formic acid. The dissociation constant of formic acid is 1.77 into 10 raised to minus 4 at 298 Kelvin. 298. Calculate its pKa and pKb of its conjugate base, of its conjugate base, of its conjugate base. So this is the problem is there. What is the problem? You have to first see on the problem. So the dissociation constant of formic acid is, dissociation constant of what? Formic acid is 1.77 into 10 raised to minus 4 at 298 Kelvin. Calculate its pKa and pKb of its conjugate base here. Then you have to find out what? You have to calculate the pKa and pKb. Okay, we know the formula. So then that you have to solution. You have to write on solution. Then in the question they are given the dissociation constant of a weak acid 1.77 into 10 raised to minus 4 they are given, and they are telling us to calculate pKa and pKb. Next we write on solution. Solution we know that what we know, pKa is equal to negative logarithm of base 10 to the Ka. Okay, they are given the Ka value that you have to put here. What we have to take here means the negative log of, what is the value they are given? Ka value 1.77 into 10 raised to minus 4 is there. Log of minus negative logarithm of 1.77 into 10 raised to minus 4 is there. So when you see this one, log A into B is there, this one. This has the 1.77 as A and this one as a B is there here. Okay. So how to solve this one? A into B is there means how to write down this one? We have to write down it what? Negative log 1.77 plus log of 10 raised to minus 14. Okay, you see here. How I have split this one? Log 1.77 into 10 raised to minus 4. A means log A into B. Log A into B. Suppose you are having log A into B, then what you are doing? Writing it as a log A plus log B. That you are writing. Minus I had left here. I had keep it here only. The outside the bracket here. So log A into B, we have to convert log A plus log B. This is the log A is there. 1.77 is there. Log A is there. This is the B is there. Log A into B. This one you have to consider as the A. This one you have to consider as the B. Log A into B is the means log A plus log B. Like that I have to. Okay, I understood this one. Okay. So here log 10 raised to minus 14 is there. Log 10 raised to minus 14. How it will be converted? Log 10 raised to minus 14. M into log m raised to n is there. Log m raised to n. Suppose I will do here the log m raised to n is there. Log 10 raised to minus 14. So log m raised to n is there. How you are writing that one? You are writing it what? N log n. This is the n is there, this is the m is there. Minus 14 log to the base 10 is there. Log base to the 10 value is what? 1 is there. 1 into minus 14, you are getting what? Minus 14 here. Like that we have to solve here. So then keep it directly, that is a minus log of, sorry, here minus 4 is there, sorry. Minus 4 is there, that you have to write on here. Sorry, log 10 raised to minus 4 is there here. Suppose it is having the minus 4 is there here. Then what happens here? Minus 4 is there means m raised to n here means minus 4 log to the 10 is there here. Means log 10 value will be what? 1 is there. 1 into minus 4, minus 4 is there. When this minus 4 multiplied with this minus, then what it becomes here? Here plus is there. Plus into log 1.77, it becomes a minus log here. So when you multiply this one, it becomes what? Minus into this minus 4. It becomes the plus 4 here. Then you have to write down You have to find out the log 1.77 value first. What is the log 1.77 value is there? That will be what? 0.2480 plus 4a. Why this plus 4 is coming here? You are getting minus 4, sir. Log 10 value is 1 is there. 1 into what? 1 into minus 4, no, sir. This minus 4 is there. If you are taking here minus 4, this minus is there. Minus into plus 4 here. Okay. Negative log is there. Log value is 1.77 is what? 0.2480 is there. So 0.2480 is there here means, so you have to take what? Minus 0.2480. Okay. So this one when you are doing here, next is what? You have to, when you simplify this one, you are getting the answer is what? 3.752. That is what? pKa. pKa value is what? 3.752. Then still we have to find out what? Still we have to find out the, that is the what? pKb. We have found out the pK. Next one is what? pKb. We know that pKa plus pKb is equal to what? 14. That relation I know, that formula I know here. So that I will write on here. We have found out the pKa. That value I have to put here, pKa value. Then it becomes what? I can write down here as a pKb. pKb is equal to 14. This pK value is there. I will move towards this one. What it becomes here? Minus it becomes. Minus 14 minus what? 3.752. Then what is the answer we are getting? You are getting the what? pKb is equal to 10.248. 10.248. So this is what we are going to say pKb. So by using this pK and pKb relationship, so we can find out what that values here. They are given only what? Ka value. From that Ka value, we have found out what? pKa value, and also we have found out the pKb values here.